It is you,
Should I,
Captain,
should I just,
Captain Charlie.
I'll just take it from here then, I guess?
Yeah, so obviously you don't need any introduction. So this is Charlie Berger, Senior Director of Product Management of Machine Learning, AI, and Cognitive Analytics. So you don't need any introduction. So everybody knows who you are, unless they live in any of the planets that appears in Star Trek or Star Wars.
That's pretty funny.
So the audience is all yours, Charlie.
All right, thank you.
One important thing, guys, for all the people that are joining us, thank you so much for being here. All these sessions are recorded. We're going to share the slides and the recordings later in our website and in YouTube channel. And if you have any question, please drop your questions on the Q&A box, here behind. And we are going to answer all your questions at the end of Charlie's sessions. Okay? Thank you so much, Charlie. All yours.
Thank you, Adel. And everyone, I cannot present and see your questions on the same screen very easily without you guys all seeing it and everything. So I'm gonna invite Adel, if there are any questions or Carrie or anyone that come up that you think are appropriate, just answer right midstream. Please interrupt and just ask the question. I'll try to get them answered as best I can. So thank you, everyone. As you can see, we've taken a little bit of a Star Wars versus Star Trek kind of theme. I had to pick a team. I like both of them. I've seen them all. I've probably seen more collectively Star Trek episodes than and movies than Star Wars, because I've seen them all like 5 or 10 times. So I went with Star Trek, and picking a character, I went with Kirk, because who else is there, right? Either Kirk or Spock. So I picked Kirk. And so a little bit of background on me. I was born on this planet like Captain Kirk. I've been at Oracle now for quite some time, since 1991, and working mostly on the always on the machine learning stuff. And what I'm going to do in today's session is try to go over here and find the other presentation that I had here, wherever it is. Not here. Where is it? This other guy down here. And so I am going to try to talk about what's coming soon, what's here, what's new, because we have a lot of new things that just started shipping. They're just rolling out from what we'd call limited availability to general availability, and those are on the cloud, things that sort of roll out. They get kind of patch updates on the different clouds around the planet, and that has just started to begun. So I'm proud to talk a little bit about the OML for Python and the OML services that are just starting to roll out now to a cloud near you. So I'll cover that and more. I adopted the quick little Star Trek looking out the front mirror kind of theme here. But before I go, straight into what's coming, I do have to do just a little bit of sort of background for those who, for whom this might be a little bit new. And so the main mantra that we say all the time is that we move the algorithms, not the data. So unlike pretty much every other player out there, Microsoft, SAS, SPSS, Python, R, TensorFlow, Teradata, you name it out there. Everyone else, the first thing they do when they do machine learning is they take the data out of wherever the data is being stored and managed, which for Oracle customers tends to be an Oracle database, right? They take it out of there, they move the data to another analytical platform, and they work with the data over there, build very good, sophisticated machine learning models, and then they're kind of stuck because they have a model over here and the data is over there, and how do they apply the model to new data? Oracle took the approach a long time ago to say that is not going to make any sense. Data is big, it's going to get bigger, algorithms are small. Let's just simply teach the data management platform how to do math and build and apply the models inside the database. And that's our architectural difference over everyone. The overall product is called Oracle Machine Learning. It used to be called Oracle Advanced Analytics. It used to be called Oracle Data Mining. The user interface on SQL Developer is still called Oracle Data Miner. We decided not to change that. Oracle R Enterprise, we renamed Oracle Machine Learning for R. And then the upcoming Oracle Machine Learning for Python is the interface, very much like the way the R interface works. It's the interface that works with Python. And then we have a new user interface, which I'll also preview, that's just coming, going into limited availability very, very soon. And I'll show a demo of that as well. So because of this architectural change that we do, Oracle's philosophy is that we try to make machine learning simple, right? Build a model in the database, apply the model, you're done. It's not this complicated, convoluted architecture that results in about 87% of machine learning projects failing to go into production. Our architecture is just by definition simpler. Now, I also always like to show this because I do think of it as a public service announcement. Everything I'm talking about, if you have an Oracle database, an enterprise edition or autonomous database, or not a personal edition, okay, but if you have the enterprise edition, SE2, or any of the database cloud service or autonomous data warehouse or autonomous transactional, the machine learning algorithms are in there and they are free, and they have been free since December 9th, 2019. Now, I always mention this because I still find many people don't know this. They're not aware of it, but Oracle announced back then through a blog posted by Willie Hardy, VP of marketing in server technology, that both spatial and graph and Oracle machine learning were now differentiating features of the database rather than separate price add-ons. And I think that just changed everything. I know my phone started ringing a lot more. Now, you'll also notice that the OML for Pi and the OML services no longer have this little coming soon because they're already here. As I said, they've been in limited availability, and they just started rolling out into general availability. The overall, I forgot to move from over here and there, so sorry for that. So the overall set of features and functions that we have is grown over the years, over the past really 20 years, to be quite an extensive an array of functionality. We have over 30, I think it's growing up to say 35 machine learning algorithms. They're all in database implementations of those algorithms. So they are not take the data out and run a neural network on it over here. They are in database implementations of that, and we can talk about how we do that. But there's about 80 something patents on that, and it's pretty interesting the way that the development team has done that. Now, when you move the algorithms to the database, it opens up a lot of opportunities and doors of possibility. One, if some of your data, say customer comments or physician's notes, are unstructured data, well, we use Oracle Text under the hood to tokenize that data and bring in what we call a bag of words. If you have transactional data, like what medications you're on, or what temperature or pressure, or various transactional data, what items you've added into your basket, well, the transactional data is the way the data is typically stored in the database, and we roll that up through aggregations and bring that in as a vector of what we call nested data. So the database tables can have nested data, and that's the way we bring in that sort of 360-degree view of the customer with transactional data. Could be geospatial data, could be unstructured data that we tokenize through and do TF-IDF, term frequency and first document frequency on that. So it is not sort of your father's machine learning platform. It is an in-database implementation of it, of these very popular and powerful and cutting-edge algorithms. And that really sort of changes everything. In the newest release, 21C, we're adding XGBoost, the very popular and oftentimes Kaggle-winning algorithm. So we have that for classification regression. And we have something that came out of labs that's been historically very popular in things like nuclear power plants, where you're really checking for process monitoring and you're looking for anomalies in a process. So there's some new techniques there. We have the OML for Python that I said is just starting to ship, and some other functionality here. So the users, depending on who you are, we have different user interfaces. Now, probably the most popular, the one that probably most people use most of the time, is the very mature drag and drop Oracle Data Miner client that is an add-in to SQL Developer. So you have SQL Developer. It's easy to try and drag and drop these little nodes over here and set up an analytical workflow. You can right mouse click on the workflow over here and save it. You can share it with others. You can set up a job to run it. And I thought I had a build on there. I guess I took that out. So if you just simply Google Oracle Data Miner, Charlie Berger, or Oracle Data Miner 5-minute demo or whatever, you can get a demo of this on YouTube pretty easily. And if you have SQL Developer, there's just a little bit of a configuration to set that up so that the user has a repository to store their models, and so that the users have the privileges to use these functions. And so under the hood, you can see what's going on over here. It's running the DBMS data mining create model code when I click on one of these nodes over here, but I have the option of, as a citizen data scientist, just dragging and dropping, and it's very easy to use. It does a lot of automation. Under the hood, when you run these nodes, they are using the sort of common base, lowest common denominator representation of the functionality or the APIs. So here, begin DBIS data mining create model, or create model 2 is another variation of this where you can specify things in line. But I give it a model name, I give it a function classification, I say a table I want to operate on, which could be select star from that table, could be a view. I give it a target field because I'm doing supervised learning here. And then I have a settings table where I would specify the settings if I did the create model 2 version. Once I've built the model, I can just say buy insurance using these inputs. So I can use dual and do it sort of on the fly, or I could do it with the whole table and I get a prediction. All of this is happening just inside the database, very straightforwardly. It's as if it's another SQL query statement. It's just a very complicated analytical query when you launch this, and it takes full advantage of all the parallelism that's available in the database. If you're an R user or R data scientist or an R enthusiast, well, we realize that not everyone speaks SQL out there for doing data science. A lot of people grew up on R. And so for a number of years now, we've had support for R, where you can come in and speak your native tongue of R to drive those same in-database algorithms. And so you'll say, I want to do a decision tree, but you won't use an R part from the open source community. You can, but you don't get any value out of that. And you have to move the data out to do that in open source R. But you can use the syntax for driving the decision tree or neural network or whatever that exists inside the database. And now you get the full parallelism and scalability of the database to do that. So you can do embedded R callouts for R packages. We support the R Oracle package for OCI connectivity. To use Oracle Data Mining via SQL, does it matter which version of SQL Developer? I see this thing pop up. Well, always use the latest version. I've got, I don't know, 20, I think, SQL Developer 20 on mine, I believe is what it is. It's so easy to upgrade, you're always going to want to use the latest version. But I go back to, I don't know how far back it was, but it's 4.3, I remember. Yeah, it worked with 4.3. And all the different releases since then, we've always updated. So you want to have the latest one, I believe, is what you should do, but it works. It has always worked with the older ones. Now, the other part of the functionality here is this transparency layer, where the R, and I say this now because in Python it'll work the same way. The R or the Python functions, like doing a T test or an F test or a select or arithmetic functions, they get pushed down to the equivalent SQL for parallelized in database processing. And that's something that we do that really no one else does. Okay, everyone else will take the data out and they'll run it in R. They'll try to maybe have some parallelized versions of R. We say, hey, we've got this database and all this horsepower. Let's just leverage what's inside the database. And then if you want to use open source R to do anything else or to prototype or experiment, you've got sort of the best of both worlds is our belief there. And the syntax here is similar, right? I'm using R syntax, call ORE, ODM AI, attribute importance for this target field here using that data table. And I just can query the results. And I could do that from SQL syntax, R syntax, or coming up Python or GUI or Notebook or whatever. We have added these recently. We've added these notebooks. They are Zeppelin based. They are available on the autonomous databases, so ADW and ATP. They've been around now for, I'm going to say, coming up on 2 years, I think it's been. We ship with 9 example notebooks. If I have time, I might jump around and try to show some demos and things here. I'm going to stick with PowerPoint for the moment. They have always been, up until just now, SQL and Markdown language limited. So you can do SQL, PL SQL, like you say, script over here where I'm running one of those functions, or just SQL where I'm doing a graph or whatever here. But then we've now added the ability to drive these through the Python language. That's just, as I said, going from limited availability and being rolled out as GA, general availability, to the clouds now, sort of as we speak. So watch that. It'll be here very, very soon. And so in total, what Oracle these days is trying to do more and more is not only manage your data, but also provide analysis capabilities. It's not just without analysis, it's just data, right? So we want to turn that into information and actionable insights. And Oracle has this whole wide-ranging set of functionality for data encryption, data backups, data querying, parallelization, blockchain, all these different things in this ever-converged, ever more capable Swiss Army knife of capabilities database. And all we've done is just add another sort of very, very sharp blades to that Swiss Army knife that are designed to do machine learning and put machine learning inside the database and accessible via multiple languages, because data science these days is more of a team sport. You have different skill sets different APIs, SQL, R, Python, and also different user interfaces, the drag and drop and Oracle Data Miner, and also the notebooks. So what's new and coming soon? So what's new is 2 new algorithms. The XGBoost, it's a highly efficient, scalable gradient tree boosting algorithm for regression and classification. If you have, I think it works well in a lot of situations, but it works out very well also when you have high cardinality, okay? So web text classification, the number of clicks on things that might be nested data, the XGBoost algorithm has been noted to do very well there. It's been used by many Kaggle winners, and now, just like we added random forest back 2 or 3 years ago, now we've added in support for XGBoost. The next one's kind of a hard one to say, MSET SPRT. It's multivariate state estimation technique, sequential probability ratio test. And that is something that comes out of the labs, Oracle Labs. There's a fellow there, Kenny Gross, who had developed this years back, and he has been quite the champion of that, and has won many awards and tests for how well this works in this type of environment. So you can see what's going on here. We have sort of a process, and we're looking for early warning detection systems. You don't want, say, your nuclear power plant or your airplane engines or whatever, they're supposed to be running nice and smoothly. You do not want them to go into a problematic state. So it is very robust to missing values that may occur sometimes off sensors. It is taking a process and monitoring that process and flagging things as an early warning system. So it's not like anomaly, we call it anomaly detection, but it's anomaly detection within a process. Now, one thing I should point out that also, I think, goes in very well with the Oracle Machine Learning Services that I'll talk about in a minute, because you may want to build a model on a batch of data that you've bothered to put in the database, but you may want to deploy the model inside the database, but you may want to push that model that you've built outside the database using the machine learning services through a REST API and do micro batch scoring of that in sort of a more real-time kind of environment. So that's a potential use case of that for you. And the last one is the Atom optimization solver for the neural networks, and it's just much faster. Okay, so you always want to try and go as fast as you can. Now, so there's a few other things here. In the 21C release, we have the new algorithms, the XGBoost, the MSET, SPRT, and then the OML for Python is also something I'll talk about. That's coming out first for 19, and I believe we're going to be pushing that back to 18. But that is first coming out on the cloud, so in the Autonomous database, and that's what's just rolling out now. So the OML for Python is just coming. You'll be able to use Python API in the OML notebooks. You can do embedded Python execution to callouts, and we package scikit-learn, matplotlib, and a subset of the whole open source library of packages. We do a subset of that because they have to go through security and be sort of vetted before we can make them available for you. But that's something that's just rolling out now. I'll have more on that in the upcoming slides. The AutoML user interface is something that's also coming. So the OML for Python is just rolling out, and the OML services is just rolling out now. The AutoML user interface is just a little bit lagging behind that. Not lagging, but just a little bit phased behind that. And that's going to do supervised learning for classification regression. I'll show hopefully a little demo of that in a minute. And then the OML services are the REST API that are coming out. You also have the OML machine learning for R that's coming out. I probably should have bumped that up to a higher level there. And the OML for R, embedded R execution. So those are all coming to the cloud after the Python goes on-prem. So a little bit of a back and forth on that. On the cloud with Oracle Autonomous Database, with the Python, the OML for Pi, that's being added to the Autonomous Database. It's just yet another feature now. When you do fire that up, somebody will probably ask, what about the cost of it? So there's no cost, it's all free, but you will consume just a little bit more, like switching on another light bulb in your house because it has to fire up the VM for the Python instance. So there's a little bit of behind the scenes that will happen there, but it's like flipping on an extra light bulb in my mind. So now you can come in and use Python syntax to drive the same algorithms or drive these, like here you're using one of the decision trees inside the database. You can also use matplotlib and such and have access to a lot more graphical results. And here's just another screenshot of that. So you can come in and use your familiar Python. Here it is using correlation on the iris data set. We overload the data visualization function. So just like the same thing we do in R, OML for R, if I want to do a box plot, I don't have to, if I have 10 billion records and I do this in R or Python, it's going to struggle with holding all that data in memory. But here what we're doing is we're pushing down the calculation, the median and the first quartiles either side and the 3 sigmas here. We're doing all the math using the statistical and database functions. We return those subtotals back to OML, and then we display the graphics. So we can scale to do many things, not everything, but the things that we already have equivalents inside the database, which are all the statistical functions, the exploratory data analysis kind of computations, the correlations, statistical summaries, the 30 some odd machine learning techniques and so on, data preparation and all of that. So it really allows you to have all the strength and flexibility that you get with Python, or similarly with R in the OML for R version of this, but also more importantly, I think, do the math at scale, leveraging the parallelism and scalability and security of the database while still speaking your native tongue of Python. And under the hood, just like the other ones, it's doing Python syntax. If you noticed on the other slide, I got 0.2161. It's running the same algorithms, in this case, the 30-something machine learning algorithms, the attribute importance, and it's giving me the same results. I'm just speaking my native tongue of Python in this case. And by the way, when we ship Oracle machine learning, we come with a number of notebooks, preset notebooks that are there available for you. I think I have that over here if I kind of go off path here. If this guy is still working, so it needs me to log in. So I'm logging into my, this is not one of the rolled out GA versions, this is my development version of this. So over here, if it's still letting me in here, okay, it is. I go over here to the examples, and now in the examples, I have the old SQL notebooks that we have down here, OML for SQL, but now we've added in a number of OML for Python examples. So here, for example, is the OML for Python with the notebook version of doing AutoML. So it's just the same Oracle machine learning that you know and hopefully like, but we've added more and more functionality for you to do more and more things. So in this case, it's booting up the Zeppelin server because I'd sort of, let it, sort of go to rest here. So it's waking it up, it's loading the notebook, which always takes just a little bit longer in the beginning. And now I have setting this up where I import my libraries that support this. I can create data sets as Panda data frames, and there are about 10 or 12 additional notebooks that you can go off and look at. And there's also on the Ask Tom series, Mark Hornick and Marcos Arancibia have been doing a great job showing off very detailed demonstrations of all of this. Now, while I'm here, I guess I'm going to go back and also show back on the home screen, or over here, I also have something called AutoML. And I am going to come back to this in a second. I'm going to go back over here. I don't want to do that. Okay. So there's the Python, and back to Python, I have the same thing I had for R. I have the transparency layer that leverages the proxy objects. So the data remains in the database. It overloads the native functions and translates the functionality to SQL. And so I can use my familiar R or Python syntax to do those R and Python things. You're using the in-database parallelized distributed parallelized algorithms, but speaking your native tongue of Python now or R. And this is coming, as I said, the Python is coming to the cloud with Autonomous. The R is already on-prem, and those will both sort of switch back and forth in the coming months. Now, also in the Python comes this new thing called AutoML. And AutoML you've probably heard and read about a lot in the, okay, so before I go into AutoML, these are the packages. People will say, well, what packages do you provide? So not everything you'd ever want, but probably the core ones that you'd want to use most often. Scikit-learn, Pandas, Matplotlib, and some NumPy, and so on. So the challenge on the Autonomous database is vetting and security checks for these things, because we can't let anybody just download anything and risk the Autonomous database getting into trouble. On-prem, you'll be able to do whatever you want, but on the Autonomous database, we've vetted and provided for you what we think are the core ones, and our goal or our aim is to keep on adding more there, but it's something that's a little bit tedious to make sure they're safe and secure, and will run properly for you there without any kind of real risk. Now, on to AutoML. AutoML is, I think of it as, instead of atomic level machine learning steps where you take a set of data, you take a sample of the data, you maybe do stratified sampling, you run maybe attribute importance to figure out what variables you can keep and what maybe you can throw out. Then you build model A, tune it, model B, tune it, model A, tune it a different way, and so on. What instead of that as an atomic level, we've assembled more of what we call it a molecular level machine learning pipeline. And this is something that we've done in great collaboration with Oracle Labs. The Labs people have sort of pioneered some of this work using Python, and we work with them to take that Python logic that sort of strings things together, but do it where it's running the Python Puppet strings, running the in-database functionality that we have. So the very first thing is this automatic algorithm selection. What that does is it identifies the best algorithms for the data and the problem, and it's faster than an exhaustive search. So earlier on, I said XGBoost is good for certain types of data, high cardinality data. Well, you wouldn't want to use a decision tree there, perhaps, right? So how do they do that? They had a wide spectrum of different data types that they've had access to, built a number of different test models and all those different data sets, and built what we would call a meta model, so you can anticipate what subset of algorithms work best on this type of data. If the data has a lot of correlation, if maybe ridge regression works really well. If the data has high amount of cardinality, maybe decision trees don't work so well. So the first step is using sort of an expert's a meta model from having built a number of models on a wide range of different data characteristics or profiles of data sets. Figure out with AutoMS what's the model selection, what are the models that would work best. Adaptive sampling, the one in yellow, then says, well, for that set of algorithms, what's the right set of data? If I have 10 billion records, do I really need 10 billion records, or can I take a 5 or 10 or 50% sample of that? And what if I have unbalanced data? I should be able to detect that and do stratified sampling on that data. So without having to think or click or anything, it's going to do that for you. Automatic feature selection is going to take that further. It's going to denoise the data and reduce the number of features that might just be sort of irrelevant. You'll see in a set of data that I'm going to show in a demo that I've got first and last name as two variables. Well, they have such sort of high cardinality, it would be odd to build a model that says if the name is Charlie, then this. I mean, I guess you could overtune, but it's going to do things like that and reduce the data that reduce those features that don't add value, in fact, add noise. And then for that subset of candidate algorithms, it's going to finish off and build those models, but automatically tune the hyperparameters so that the depth of the tree growth, the complexity index in a Gaussian support vector machine, and so on, all the different parameters that you could sit there and exhaustively run, it'll do that for you. So the AutoML user interface is a different kind of look and feel than what you would have with the Oracle Data Miner. It's up on the cloud, so it's using a different sort of user interface. It does not have the data transformations. It does not have the extensive graphics that you have with the Explorer node. Some of these kind of things yet. This is still a little bit of a work in progress, but the core, I guess you'd say, the minimum value, minimum feature, what is it, an MVP or whatever, minimum viable product, certainly, and more, is out there now, and I'll show you a demo of that in a second. It's very easy to use. I think I claim it's 6 clicks to a good model. Minimal user input, automates all these different steps I described. It'll generate the notebook at the end of these steps. You can deploy the models, either just doing it inside the database or using the REST APIs to deploy that. So we're trying to make machine learning simpler. Currently, we're doing classification and regression techniques only. Now, following on the heels of that, we'll also do some other techniques, things like anomaly detection and time series, most likely. And then we'll just keep going from there. But you go into AutoML, you click AutoML, and I have this as a quick little demo. What I'm going to try and do, and let me see if I just do this real quick. This is a little demo I inserted in here, and it kind of walks you through everything. Whoops, I forgot to turn off the sound. Okay, so it walks you through everything. I'm going to see if I can't just get this thing to run real quickly on here. It always doesn't run and go as well as you hoped, but I'm going to see if I can't do that. I'm going to say I'm going to create a model. I'm going to give it a name of the model is targeting insurance customers. Okay, so we'll do that, and my data source will be something that I've access to here, and I have access to this very familiar customer insurance lifetime data set. And if I want to do the prediction target field, I'm going to do by insurance. I can do a little type add here. My unique identifier is going to be customer ID. And then that's all I do. It's going to intuit that it's probably classification rather than regression. It's going to look at all the different variables that I have down here, where it's done a little bit of profiling on that data. And I'm just going to say save, just because it's a good idea to save. And now when I'm done here, I can start this. I can do faster results or better accuracy. I'm going to say faster just because we're kind of in a hurry here and I'm watching the clock tick by. But this saves it as an experiment. This is the machine learning pipeline that's going to do all those different steps that I described earlier. And with very little sort of effort here, it's going to set up a sequence of steps. Now notice it says here 0.73. That means the overall accuracy of this model is the priors. 73% of the people do not buy insurance, 27% do. So already I have an issue about adaptive sampling. I'm going to do stratified sampling. I don't also necessarily need to use all of the data to build this model, but what the AutoML is doing right now is it's said, what are the algorithms that we think would work best on here? Okay, so out of all the available algorithms that we have, it's going to look, notice I don't see a naive Bayes for some reason. It just doesn't think naive Bayes is going to do that well here. So it's reduced that down, saving me a little bit of time already. It's already done the sampling. It's now doing the feature selection, which says of the variables down here, which of these variables are the ones that have the most impact. So this is like your attribute importance. Well, it basically is your attribute importance, but it does also some statistical correlations, and it does two other techniques. I think it does a random forest and use the attributes there, and it does another technique, and then it takes the sort of the average of all those guys, or what the net of those guys, the union of all those predictions. So it does that over time. You can see the model keeps on getting a little bit better. I've built a model here that's 92, almost 93% accurate, and it's just kind of shuttling through all this data here, building the model. It's going to build the next one, the next one, the next one. I'm going to let this thing go for a minute, come back here. It should just take another 2 or 3 minutes, but I'm watching the clock tick by here. I'll come back and show you this. But notice when I'm done, I'll be able to take a model, create a notebook. I can deploy it. I can do a bunch of different things over here. So I'm going to let this guy finish out. I'm going to go back to PowerPoint. And what else do we have down here? See if there's anything else. We finished all the models here. I can see additional metrics, okay, ROC, things like that. I can see for any particular model, I can see the overall features. I can, well, get out of there pretty quickly. I guess I clicked in the wrong place. So if I click right there, so now it's oh, I know what I did down here. I think I'll show it this way quickly because once I've built a model, I can come down here and say create a notebook. So I'll say, yes, I do want to create a notebook. And now, whoops, and then that is turn off the sound. So now that creates a notebook. So any one of these notebooks, I can just see the notebook that it's created. There's the code that it created. It's in Python code because I explained in the beginning, it is Python code. But also that model exists. So if I want to come in here and take a particular model, I can deploy it as a REST API. I can also, I think I show it, there's the model. Well, that's a different one. I also show it in here as a model, I believe, somewhere in this flow, where I can take the model and just create a SQL paragraph and just store it right in the database. So I can create an experiment, pick a data source, pick the target attribute, pick a data, see the data profile, set it up to run, see the attribute importance, see the leaderboard as it runs along, see it do these model summaries. I can create a notebook. There it is, the notebook I created behind this, it's already behind the pop-up window there. Or I could do, here it is, a screenshot of create table from where I make a prediction, and there they all are. Now, what's nice about this is there's the predictions. I've got Apex, OAC, anything I want to start accessing that. So I, as a citizen data scientist, was able to build a pretty good model with this rigorous exploratory machine learning pipeline that would be employed by a data scientist, and I've got a pretty good model. If I'm a data scientist, I could maybe try to tweak this, maybe try to improve it, but I've automated a number of steps there, and I can go directly to deployment now. I can deploy it via the REST API points, which is part of the OML services that also is now going to GA on the autonomous databases. I can manage models as well. I can deprecate a model and version the models now. And I can also score on the AutoML services Onyx format model. So if I have a third-party Onyx model, which is an industry exchange, that could be an image model for classifying images, like that is a beagle. That's actually my dog, Sir Barks a lot. then I can do that. So I can take an Oracle machine learning model and deploy it outside the database, or I can take other third-party models. And in the OML services, you have a number of functions for, this over here, for administration, repository to store a model, update the model name, deployment, create a model endpoint, score using the endpoint, and so on. So there are, Marcus Arancibia has in GitHub a number of examples there you can use to go see that. So if you go into the Oracle database examples, go to the OML services, you can see all the examples that he's put out there, and they're just wonderful examples that walk you through all that. Also, there's some of this on the Ask Tom series. Now, I'm going to take questions at the end if we have time. I'm going to go into what is new and different. So that's the OML for OML services and OML for Pi are just transitioning from limited availability into general availability on a cloud rollout near you. So I don't want to, we've been saying the dates for so long now. I'm just going to wait for it to appear, and you say, oh, there it is. He said it was going to be there. Now I see it. And you'll notice that by going over to the examples, you'll notice that there's not just the SQL examples. Now you have the Python examples over there. That'll probably be the easiest way for you to see that. Something that I think is really pretty cool that I've been spending a lot of time on these days also are these hands-on lab environments. So real quickly, I want to go through this. These are something that I think are new, and one of the coolest things to do. You can come over here. Where is it? Over here, and you can just go to the Oracle Live Labs. You can click, if you're like me, click on AI ML. And when I do that, you'll see this guy here, which if I click on that, opens up this tab over here, but it opens up that tab right there. I can reserve this, and I'm just going to do it for fun, I guess, right now, just to show you how this thing works. So it's going to ask me, I got my phone charging over there, so I can't do this right now. It'll ask me for my PIN. I'll have to type in my PIN, and off I go. But you do need an account. I should have had that set up already, but I've got screenshots for this. So come back over to here. Once you click OK, in about 4 to 15 minutes, if I say, just do it now, you'll get 4 to 15 minutes from now, it'll fire up a whole autonomous database for you. You'll launch your workshop. You've got 4 hours with it then. So for 4 hours, you can play with this, do whatever you want. And we've been doing some hands-on labs. You'll get these notifications from email. You'll say it's all ready to go. You'll log into here. Remember your password. You'll log in with that. We also, we say this green button because when we do the green button, we load up a bunch of data for you as well. You're going to log in with your username, your admin name. You're going to copy and paste that password. You're going to go over to here, and you're going to find the same compartment where you're in, 2008, Live Lab 2008. You're going to find that. And when you find that compartment, the autonomous database will have already been created for you. Totally free. Now, the product, if you already have the Oracle database, it's all free. But this is, you can just use this every 4 hours. I've done 20 or 30 of these things all for free. You just keep on going with it. You launch the services. You manage OML users. You create a new user. You sign in as the new user. You come into the hands-on lab environment. You select some notebooks. Here's one of the ones we're doing. We load up all this customer insurance. No, this is the credit scoring 100K data set here. I think, yeah, credit scoring 100K data set here that we use. This notebook is all documented in the Live Labs, as are other ones. You can build the models, see the results, see the predictions. You can even change this from using, instead of rich, change to poor, rerun the model, click OK. It'll change that to score to like 1% probability. Now, we're not quite done yet because, as I said before, where are all these results? They're in the database, right? So I might as well just come in here and build nice, simple little applications using Oracle Apex to query and peruse through my predictions, because I don't want to look at a notebook all the time. I want to share this with some of my colleagues or my management. Here's the attribute of importance I showed you a few screens back. I just probably want to show that as something through Apex. I can have interactive graphics like this where I can say, these are all the people that have a high probability of leaving. They've been with the company a long time. I may want to drill down and see who these people are and maybe decide to take some action. Wait, there's more, and we'll have more on this in an upcoming TechCast. Philippe Leone will come in and tell us the latest updates on what OAC is doing to now integrate with the Oracle machine learning models. So you'll register a model, or you can just point to the results, just like Apex did. The results are there, just point to them. Here you can also go beyond that. You can say, I've got a data set. There's a model, let's say my data scientist has built. I'm going to apply the model in a little flow here, and now I can query that. Okay, so I can query it, make graphs or whatever. This is one of my favorite ones. Notice this little DM, dollar, DL, wine, whatever. That is the object name for the model name for the support vector machine that does text mining as well. And we're querying that model object in the database and using all the impressive graphics that come with OAC to find all those words, the unstructured data that are most associated with predictions of good wines and predictions with bad wines. So you can really just take the machine learning and take it so much further. And then you're on your way to becoming an Oracle data scientist. I say Oracle because you're leveraging first and foremost the platform, the Oracle database, this converged database with this ever richer assembly of functions. There are a number of links. I think I'll put that in the chat window if you don't have it already. So all those notebooks I was going through for the live labs and such, you can just download those over here. And with that, I'll say thank you very much. Sorry to run just a little bit over time. We're sort of leaving the universe here, leaving the galaxy or whatever, and I'll see if there's any questions.
Yeah, there are a few questions here. One is about what Oracle database version was the first one that has Oracle machine learning integrated for free. I don't remember if 11 or 12.
For free, it's not a release. It's 12. I think it's 12.2.
12,
but the free happened on December 9th, 2019. So it was already 18 or 19 at that point, but they went retroactive back to 12.2, I think it is. Yeah.
Okay, perfect. And we have a question from Rich Dusatko. Hi, Charlie. We're looking to apply machine learning technology to assist in improving our fraud detection monitoring procedures in 2021 with use of OAC machine learning. Can you advise if you have any recommended use case tutorial documents you can recommend to help us get started?
Yeah. Hey, Rich. Hi. Yeah, I do have some stuff here. I'm going to share my screen real quickly. I think we have all the way up, like just a few more minutes here. We got to get our guest guy on here next, but let me show this real quickly. If you go to, and I'll try to put this into the two-step process here. It is. This is something that we also have a hands-on lab. I think I'm doing that March 4th, I think. But if you come into here, this is I think it's very nice. I got this, I stole the idea or collaborated with, I guess I'd say, Abby, who's on the call also, who had done a lot of this kind of work at UK National Healthcare System, working with our next speaker, Phil, and we had done something together, leveraging what she was doing, and I just kind of took it a little bit further with a certain data set, put it out here as a blog, and this walks through the whole setup with a two-step process, and you can read this at your leisure, but I would recommend that. I'll put this in the chat window as we go here. What else? Any other? I want to make sure we have time for our next for John.
Yes, just another one that MSET SPRT is for univariate time series, or is can it work with multivariate series?
Multivariate. It's the very first. Yeah, multivariate. It's the very first word.
Multivariate.
In the M.
Perfect.
Yeah.
Perfect. Great.
And if anybody has any questions, follow up. Just please just send me an email. I'll do my best to try to help you out with that.
Okay, just only one. What is the set of algorithms that our auto machine learning selects best 1 out of?
All the ones that the classification regression ones. So the naive Bayes, support vector machine, neural network, random forest, SVM, GLM, generalized linear model, rich regression or not, and so on.
Perfect.
Yeah,
Perfect. Thank you so much, Charlie. It was great content. A lot of excited new features that are coming soon. So I think we're good.
Great. Thank you.